Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So to find the area of a rectangle, we just multiply the width and the length. That's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared. And then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. So in this question, we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement. And we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here. And so that would be minus 4, 1. Integer just means whole number. So we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now A and B have to be the parallel sides. So here we've got the two parallel sides here, which just pick a different colour, here and here. So that is A and B. And then the H is the perpendicular distance between them. So perpendicular means it hits it at right angles. So that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of the circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part. And it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93, blah blah blah. And when you do that, you get 140.061, blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one, and then the h is the perpendicular line that hits both of them at 90 degrees. So what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute, so it would be 50 minutes. So asked to find the bearing of Freetown from Gamley, so that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA, and so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in, and we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah blah blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah blah blah, and that gives us 243.434, blah blah blah. It says it wants it to the nearest whole number, so that's going to be 243. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. The parts of a box plot are that the lowest value is on this side here. The lower quartile is this bit here. The median is this bit here. Upper quartile, and then the highest value. So the median is this part here, and we can see that is at 23. So the median is at 23. So looking at the graph straight away, we know that the y-coordinate of point A is 0. And we're told that it's y equals tan x, and you just need to know the graph y equals tan x. And if you know the graph, we know that that will be 180 degrees. We know the point at which both of these lines will be going towards would be 90. This point here will be 270. And so therefore this point will be 360 degrees. So it's going to be 360, 0. So we're going to start by labelling the sides here. So we've got capital A up here, little a down here. It doesn't matter which one you label. Capital B here, little b here, then capital C here, little c here. So you notice the C's aren't really involved at all. But we've got the two A's, we've got the capital A and the lowercase a, and we've got the capital B and the lowercase b as part of the question. And so when you've got a pair or two pairs of angle and sides, you are going to be using the sine rule. And so the sine rule says that sine capital A over lowercase a is equal to sine capital B over lowercase b. Now you might be wondering why I've put sine A and sine B at the top, when sometimes this is written as the lowercase a and lowercase b at the top. Well, if we're looking for the angle, which we are here, we're looking for capital A, you put the angles at the top. If you're looking for the length, you put the lengths at the top. Okay, so we're going to fill this in. So sine, we're just going to leave that as sine A, because it's just, or sine x actually, shouldn't it be? Sine x over, and then lowercase a is 6, equals sine B, the angle is 35, over lowercase b, which is 7. Okay, we're going to work out what the right hand side is. So that's going to be 0.081 blah blah blah. And then we're going to be solving this. And the first thing we're going to do is times by 6 both sides. So we get sine x is equal to 0.491, blah, blah, blah. And then we're going to inverse sine both sides. And so we have x equals 29.448, blah, blah, blah. And our answer wants to be rounded to 2 decimal places. So we're going to put our answer as 29.45 degrees. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'll be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times, first of all, then our frequencies, and then we can add a midpoint and an fx column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the fx later on. Right, so the first group is 0 to 10. And to find the frequency, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2. So 10 times 1.2 will be 12. And then the next group is up to 30. So we're doing 20 times 3.2, which will be 64. And then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean. So hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40. And then the fx, we just times these together, and that would be 60, 1,280, and 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1,980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521, blah blah blah, and 2 decimal places, which is what the question asks for. It's 21.52. Cos x starts at 0, 1, and then goes down to 0 at 90, down to -1 at 180, then back up at 270, back up to 1 at 360, and then that just repeats forever. But we're asked to do y equals 2 cos x, so each of the y coordinates will be doubled. So it will start at 2, still go down to 0, but then go down to -2. Still go back to 0, go up to 2, then down to 0, down to -2, and it will just keep bouncing between 2 and -2. When you're drawing the graph, make sure it's got a nice U shape at the bottom and the top. They will penalise a V shape. And my graph is not perfect, but that's more than good enough to get the marks. When we have a times 2 inside the function, so it's 2x, it actually does the inverse to the x coordinate. So it actually divides all the x coordinates by 2. So if we see this coordinate here, which is 2, 3, that will now become 1, 3 on our graph. Okay, and this one here is at -2, 3, that will be -1, 3. And similar to all of these points, so we're just dividing each of the coordinates by 2, we're halving each of the coordinates. And so what you'll end up with, and we're just going to try and roughly sketch this out, it's not going to be perfect, but there's a graph that looks something like this. It will still cross the y-axis at the same point, and then we're going down to about here, back up again, and somewhere there. I reckon I could probably do that a little bit better, maybe, I don't know. And this isn't supposed to be perfect, but the examiner can clearly see that I've halved all the x coordinates. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.